Hi everyone, welcome back to our channel. In this week's video, we'll cover one of the most commonly asked questions we get from our customers. Whether it's a AA, AAA, a battery pack, or portable power station, we're constantly asked, what do these units mean? So in this video, we'll explain what each unit are so that you can have a better understanding of the batteries and how to use it to your advantage. If you find this video helpful, please like and subscribe to learn something new every week. Alright, let's get into it. We'll start with household batteries, like AA or AAA batteries. On any household rechargeable batteries, you'll often see two units displayed on the label, V and mAh. V stands for volts, which is a unit measuring voltage. It indicates the electric potential in a battery. Keep in mind that the voltage value you see on a battery label is not its actual voltage, but a nominal voltage. And a nominal voltage is the voltage of a fully charged battery when delivering rated capacity at a specific discharge and condition, measured at the midpoint between fully charged and fully discharged. For example, on this chart, you can see the Tenergy nickel metal hydride AA battery voltage curve during discharge. This battery voltage was close to 1.5 volts when fully charged, and at the end of the discharge, the voltage will drop to 1 volt. When you measure the midpoint, you get 1.2 volts, which is why the nominal voltage of the cell is actually 1.2 volts. The battery's nominal voltage also depends on its chemistry type. For example, a nominal voltage of nickel metal hydride and nickel cadmium cell is 1.2 volts, while the nominal voltage for an alkaline cell is actually 1.5 volts. It's important to pay attention to this unit when you want to check whether or not it's compatible with your device. Each device requires a specific voltage for it to work. Using a battery with higher or lower voltage will affect the device's performance or even damage it. For most household electronics that use AA, AAA, C, or D batteries, voltage isn't a big concern since these devices are designed to work with 1 volt to 1.5 volts already. Alright, moving on to mAh. This is 1,000th of an amp hour. An amp hour is a unit that measures how many amps the battery can deliver in an hour. This unit generally describes the battery's rated capacity. For example, this AA battery has a rated capacity of 2,800 milliamp hours, which means it can power a device drawing a current of 2,800 milliamp for 1 hour. If a device draws less current, the battery can deliver more runtime and vice versa. You can calculate the estimated runtime by dividing the battery's capacity to the device's current. For example, this Xbox controller here draws 450 milliamps. So the estimated runtime when using these batteries will be 2,800 divided by 450, which will give you about 6.2 hours. This milliamp unit will let you know how much energy is stored inside a battery, and the higher the value, the longer it lasts. Also, keep in mind that these are just estimated runtime. The actual runtime varies by a lot of conditions, such as C rating, temperature, applications, and maintenance. You probably can't find milliamp hour unit on a non-rechargeable or disposable battery, since its capacity can vary depending on the device's draw current. You can check out this video to learn more about alkaline batteries. Speaking about current, it's a flow of electrons in a unit. This is measured in ampere, or amps for short. Depending on the device, a battery can deliver a different amount of amps. For example, the flashlight I have here has multiple brightness levels. The battery will draw a higher current to power the flashlight at 100% brightness versus if it was at 10% brightness. So keep in mind that every battery has a limitation on the number of amps it can produce. We'll cover this more when we talk about C rating. Now let's see what units are mentioned on a battery pack's label. I'll use this LiPo battery pack as an example. This battery has a nominal voltage of 7.4 volts, and its rated capacity is 1,000 milliamp hour. So that means it can power a device that requires 7.4 volts for an hour at 1,000 milliamp power draw. Here is something new, 20C. What is 20C? The letter C here stands for C rating. It's a measurement of the current in which battery can be discharged or charged at. Usually, the C rating you see on a battery pack label indicates the maximum amount of amps it can produce constantly. In other words, it's the battery's current limitation. In this case, 20C means the maximum current this battery can constantly produce is 20 amps. If you're curious how I got this value from a C rating, you can check out this video up here. Back to the topic. C rating here lets you know what's the highest current the battery can be discharged at, which is 20 amps. With this knowledge, you can check to see if your device draws a higher current than this or not. If it is, then you might want to choose a different battery with a higher C rating or a higher capacity. Now that we've covered some of the main basics about the units on the batteries, let's try understanding something bigger, like a portable power station, to see how much we know about it. Even though it looks different and is more complex, it's technically still a battery pack, but on a bigger scale with more functions. Okay, are you ready? Let's take a look at the T320 technical specification. Here's something new. The T320 portable power station has a capacity rating of 300 WH. So what is WH, and why isn't amp hour the unit used to measure the battery capacity? So WH stands for watt hour, and before we were talking about amp hour. Both units indicate the amount of energy a battery can hold, but watt hours acknowledges the battery's voltage while amp hour does not. So amp hour can be confused when you want to compare the stored energy between two batteries. Let's use these two for example. They both have a capacity of 2000 milliamp hour, but that doesn't mean they store the same amount of energy. This is when you use watt hours for comparison. You can calculate watt hours by multiplying the battery's voltage with the amp hour. So the watt hour for this AA battery will be 1.2 volts times 2 amp hour, which will give you 2.4 watt hour. And the watt hour for this battery pack will be 9.6 volts multiplied by 2 amp hour, which will give you 19.2 watt hours. Now you can see the battery's pack has a lot more power than this AA battery. Moving on. The T320's input is 15 volts and 3 amps. We already know what these units mean. But here's something new. If you multiply 15 volts with 3 amps, you'll get 45 watts, which is a new unit. Watts, or W, is the unit of power that measures the rate of energy transfer. In other words, watt indicates the amount of energy consumed by a device. So in this case, we learned that the portable power station will consume electricity at a rate of 45 watts during the recharging process. You can also calculate the estimated time it takes to recharge this portable power station by taking its capacity in watt hour and divide it by the power in watts. So the estimated charge time will be 300 watt hours divided by 45 watts, which will give you about 6.67 or 6.5 hours. So that's our last unit that we'll cover in today's video. The rest of the specification shows how many output ports it has and how you can use the power to recharge your devices. Each port will provide a different voltage, current, and power. But you've already learned what those units mean, so it shouldn't be a problem deciphering them. We hope you find this video helpful. If you have any questions, we'll be in the comment section, so feel free to leave one down below. We'll see you next week.